Next, we are going to discuss about the horn gap. The horn gap consists of two horn-shaped rods, which is actually separated by a small distance. One end of is connected to the line, and the other end is connected to the earth. You can see in the diagram. Actually, the diagram is with and without the series resistance. The choke connected between the equipment is actually to protect the horn gap, which actually serves for two purposes. The steepness of a wave incident on the equipment to be protected, which will be reduced. Next one is it reflects the voltage surge back onto the horn. So these are the two purposes. Next you can see here whenever a surge voltage exceeds the breakdown value of a gap, a discharge takes place and the energy content in the rest part of the wave is bypassed perpendicular to the ground. An arc is set up between the gap, which acts like a flexible conductor and rises upward under the influence of the electromagnetic forces, which normally happens in the diverters. Thus, actually increasing the length of the arc, which eventually blows out, which won't sustain. There are two major drawbacks in the horn gap. One is the time of operation of a gap is quite large as compared to the modern devices or modern protective gears. And next one is if used on isolated neutral, the horn gap may constitute a vicious kind of walking grounds, which will be a visual one. For these reasons, the horn gap has almost vanished from important power lines. So nowadays, it is an outdated one. So these are the points you have to keep in mind while writing the horn gap. Next, you can see here normally the surge diverters, which should have following basic requirements of a surge diverters. So you can see the first one, it should not bypass any current at normal or abnormal power frequency voltages. It should break down as quickly as possible after the abnormal high frequency voltage actually arrives. It should not only safeguard or protect the equipments for which it used to be, but should discharge the surge current without damaging that or by itself. It should interrupt the power frequency which actually follow current after the surges are discharged to the ground. So in this, namely we have three types. One is a rod gap, next one is expulsion type, and finally we'll be having a valve type for lightning arresters. So next we are going to see about rod gap. This type of surge diverter is perhaps the simplest and cheapest and the most rugged one. You can see in the figure. This one such a gap for a bearing bushings, breaker bushings. This may take form of walking rings, which normally the breakdown characteristics of a rod gap. For a given gap, the wave shape of that particular voltage, the time for breakdown varies approximately inversely with the applied voltages. You can see the graph. Next, the time to flash over actually for a positive polarity is lower than that for the negative polarity, which normally happens in the arresters. Also, it is found that flashover voltage depends to some extent on the length of the length of that lower order. For low values of this length, there is a reasonable difference between the positive and negative flashover voltages. Usually, a length of 1.5 to 2 times the gap spacing is enough to reduce the difference between that reasonable amount. The gap setting normally chosen in such a way that breakdown voltage is not less than 30%, which is a nominal value, below which the voltage withstand level of the equipments to be protected. This has to be emphasized. So even though the rod gap is the cheapest one, it suffers from major disadvantages. That is, it does not satisfy one of the basic requirements of lightning arresters actually listed in that list. It does not interrupt the power frequency follow current. This means that every operation at the rod gap results in the LG fault, that line to ground fault, and the breaker must operate to de-energize the circuit to clear the flashovers. The rod gap, therefore, is generally used as a backup for the protections. Next, we are going to see about the expulsion type of lightning arresters. You can see the diagram. Here we have a line, we have a series gap, then we have a lengthened gap with fiber tubes, At the bottom, you can see here, bottom metal electrodes. Finally, you have a vent for gases. So you can see in the diagrams. So with this only, we are going to elaborate how the expulsion type of lighting arrestor is going to function. And improvement of rod gap is the expulsion type, which actually consists of a series gap, as I said earlier, external to the tube, which is good enough to withstand normal system voltage. Thereby, there is no possibility of corona or a leakage current across that particular tube. Next, you can see here a tube which has a fiber lining. You can see inside you have a fiber lining. On the inner side, which is highly gas evolved materials. Next, you have spark gaps. Then you have in a particular inside the tube an open vent at the lower end for the gases to be expelled. You have at the bottom you have that provision to expel that particular gases. It is desired that the breakdown voltage of that particular tube must be lower than the insulation for which or what it is to be used. You can see here this kind of expulsion type nowadays it is replaced or completely the rod gap is replaced by this expulsion only. Next, we are going to see about surge protections for rotating machines. So it is applicable for rotating machines. Even simply we can use it for arresting that particular low voltage. Normally, you can see here a rotating machine is less exposed to the lightning surges as compared to the transformer, because transformer which is exposed to the atmosphere. Because of the limited space available, the insulation on the winding of rotating machine is kept to a minimum. The main difference between the winding of rotating machine and the transformer is that in case of rotating machine, the turns are fewer but longer, and are deeply buried into the stator slots. Surge impedance of rotating machine is approximately nearly 1K, that is 100,000 ohms. And since the inductance and capacitance of windings are large as compared to the overhead lines, the velocity of that particular propagation is lower than that of the lines. For the analytical purpose, that the machine it is a 15 to 20 meters per microseconds. This means that in case of surges, the steep front, the voltage will be distributed over the concentrated at the first few turns. Since the insulation is not immersed in oil, its impulse ratio is approximately unity, whereas that of the transformer is more than 2. These points you have to keep in mind. The rotating machine should be safeguarded against major and minor insulations. By major insulations, which mean the insulation between winding and the frame, and the minor insulation means interturn insulations. These differences you have to keep in mind. The major insulation is normally determined by the expected line to ground voltage across the terminals of the machines, whereas the minor voltage normally it is determined the rate of rise of that particular voltages. Therefore, in order to safeguard or protect the rotating machines against surges or over voltages, it requires limiting the surge voltage magnitude at the machines, particularly at the terminals, and sloping the wavefront at the incoming surges. This point you have to keep in mind. To safeguard or to protect the major installations, a special lighting arrestor has to be connected at the terminals of the machines, and to protect the minor installations, a condenser of suitable ratings has to be connected at the terminals of the machines. So these are some of the techniques we can adapt to protect our devices against the over voltages.